This is a short introductory video about how to use a thermal imaging camera. Now, the thermal imaging camera is used in many applications in building surveying and engineering, but it's very important you understand how it works if you're going to get the correct results. In this session, we're going to look at the parts of the thermal imaging camera and take a look at some of the common errors people make when using them. There are 5 parts of the thermal imaging camera that you should be familiar with before you use it. There's the lens, which takes in the image, the battery compartment, where the power is supplied, the standby switch at the back, which turns the camera on, an autofocus switch at the top, labelled A, and a small screen which shows your results. When you're using a thermal imaging camera in a laboratory or in the field, there are 3 things you need to make sure. Firstly, you must never touch the lens of the camera. This will damage its ability to take images. Secondly, you have to make sure it has sufficient battery power for the project you're undertaking. This camera has a high processing power, and so it gets through batteries quite quickly. Finally, you need to ensure that the correct memory card is inserted at the back of the camera and there is sufficient memory on that card for the project you're undertaking. The most important thing about using a thermal imaging camera is to remember that it is not taking direct thermal images. This camera is looking at the emissivity of surfaces and then interpreting them as a thermal portrait. In order to use this camera correctly, therefore, you must understand the theory behind emissivity, black box emitters, and how this camera interprets thermal signatures. To demonstrate the difference between emissivity and heat, we will now run a short experiment. Here, I have a hollow steel box. Half of this box I've covered with black insulation tape. Common stuff used to insulate pipes and electrical wiring. The top half of the box is exposed steel. Both of these surfaces have different emissivity ratings. The insulation tape has an emissivity of about 0.97, whereas the steel has a much lower emissivity of 0.07. If we pour boiling water into this cube, we will see very different results from the 2 surfaces. At the moment, next to the kettle, the cube, here, is appearing as one temperature. However, when I pour hot water into the cube, you can see the real difference emissivity makes to the thermal image. The lower part of the cube, which is covered in high emissivity tape, shows a high temperature. However, the upper part of the cube, with low emissivity steel, shows a much lower temperature. In reality, we know that both of these 2 surfaces are the same high temperature. Obviously, we know that that cube is the same temperature throughout. However, if you use the crosshairs of the camera, you can see that the lower part of the cube is registering at 76 degrees, whereas the upper, low emissivity section of the cube is displaying at 25 degrees. This highlights some of the problems of using a thermal imaging camera to determine the temperature of the surface without first understanding the complexity of emissivity. Once you understand the emissivity of the materials that you'll be investigating, it's important that you calibrate the camera relative to those emissivities. Now, the calibration of the camera is a complicated business, but it can be found in detail in the camera's manual. After calibration, another element to consider is the range. In this case, the temperature range in shot is wide, and the camera is using an automatic function to determine the range. However, in some functions, the temperature range may be quite small. For instance, looking at the insulation in walls. In these cases, you can select your own range. This is done through the menu on the camera. Here, you have a number of different ranges you can select, or you can input your own range depending upon the materials you are investigating. That concludes this short introduction on using a thermal imaging camera. Further details on the technicalities of using the camera are available in the camera's manual. There are also a number of videos on more specific site applications for thermal imaging.